This is a Friday Shoes production. Today's target, I can evaluate algebraic expressions using the order of operations found in lesson 1-2 on page 29 in your book. First of all, let's discuss what we've done already. We've been talking about numerical expressions in the order of operations. You kind of see that down there on the left-hand corner. And then we've evaluated there on the right side. Actually taken the math and simplified, evaluated, and found our answer. Well, today we got to introduce you to the basics of algebra, which involve variables. Variables are letters, could be symbols, to represent numbers. We like to use letters as math teachers. Now, an algebraic expression has a variable, and it has a number, and it has an operation, or more than one operation. You can see that up in the right-hand corner. Our main focus is just evaluating these algebraic expressions. To evaluate or find the value of an algebraic expression, first replace the variable or variables with the known values to produce a numerical expression, one with only numbers and operations, like we've done in the past. Then find the value of the expression using the order of operations. So it's one more step added in than a numerical expression. Take a look at that first problem. It says evaluate 6 times the quantity x minus y to the second power when x is 7 and y is 4. So the first thing we're going to do is take this 7 and this 4 and put them in for x and y. So I'm going to rewrite this math problem with the x being 7 and the y being 4. So 6 times the quantity of 7 minus 4 to the power of 2. Now it looks just like a numerical expression we've been doing in the past. Step 1, using our order of operations, we're going to do 7 minus 4, which is 3. We have the square on the outside of the parentheses. And now we know that when we have parentheses and there's a number outside those parentheses, that means multiplication. So that's why I wrote down 6 times 3 to the second power. Let's do 3 to the second power. That's 9. And then let's take our 9 times 6, and that's 54. There's our answer. Here's another one. Evaluate g to the second power minus 2 times g minus 4 when g is 5. Let's plug this 5 into the g for both of these spots. So we'll take the expression and make it a numerical expression by putting in that 5. Now this 2g right here really means 2 times g. So I'm going to take 2 times the 5 that I'm putting in. It doesn't become 25. We have a minus 4. Now we have the numbers plugged in. Let's do simplifying. So we have 25.
Ariana Street to the main office.
Excuse me.
Ariana Street to the main office.
Now we have minus 10. We can do this as our multiplication. Then we have minus 4. So we'll do 25 minus 10. That's 15. And then minus 4, which is 11. There is our answer. Why don't you give it a try here? There's a couple expressions for you. C is 3 and D is 7. Plug those numbers in and work these two problems on your own. And I'll do them while you're doing them. First step, of course, is plugging in the numbers. So I'm going to take the D and replace it with a 7. Take the C and replace it with the 3. Put our square symbol out here, plus 1. I have to work with parentheses first. If you remember, please excuse my dear Aunt Sally. Exponents, parentheses, exponents, multiply, divide, add, and subtract. So we had 7 minus 3 first. That's going to be, 4. There I was adding. There's 4. That's kind of ugly. Let me change that. There's 4. We'll put the square on the outside of it since there's nothing else there, but we'll take the 4 from the front and plug that in as a multiplier. Plus 1. Next thing we do is exponents. now that we're done with the parentheses, it's got to be 4 to the second power. That means 4 times 4. 4 times 4 is 16. We talked about that today in class. Then we got 4 times 16. I do that in my head, that's 64. Someday you'll be able to do that. Some of you may still be able to do that. So we have 64 plus 1, that's 65. That's our answer. Let's circle it. Second one over here, let's plug in 3 for C and 7 for D. So we have 6 times 3. Notice I'm putting a dot in there so I know it's multiplied. That's what it stands for. 3D is actually 3 times D, which is 3 times 7. So we have 6 times 3, which is 18, plus 4 minus 3 times 7, which is 21. I did the multiplications next.
Haley, Conlon to the main office, please.
Excuse me.
Conlon to the main office.
We've got our 22, and we got our minus 21, which is 1. So there you go. Hopefully those are the ones you got right. What about fraction bars? Well, fraction bars are handled the same way, except you do the top first, then do the bottom, then take the top divided by the bottom. So let's take our 9 and plug it in for M, and take our 5 and plug it in for N. So now we have 4 plus 6 times 9 all over 2 times 5 minus 8. Now we have to do our top, then our bottom, and then we can divide the two. So the top I'll do together. Let's hear 4 plus, let's do our 6 times 9 because that comes first in our order of operations. That'll be 54. And then 54 plus 4 is 58. On the bottom we've got, looks like we're going to do this first. That's going to be 10 minus 8. 10 minus 8 is 2. So then we take 58 divided by 2, and that would be 29. Why don't you give it a try down here on these two problems when P is 5 and Q is 12. So stop the video and you can try it on your own. Here's me doing it. 3 times 5 minus 6 all over 8 minus 5. So now we have, on the top we'll have 15 minus 6, and on the bottom we'll have 8 minus 5, which is actually 3. We can do that, get that one completed. 15 minus 6 on top, that's 9, so we end up having 9 on top and 3 on bottom, which then is 3. There's our answer. Over on the right, same thing. Let's take our Q, plug it in, and then take our P and plug it in. We have both in this case. So we have 4 times Q, I'm doing this part right here, which is 4 times 12. And then I have on the bottom 12 plus 2 times P, which is actually 5 plus 1. Looks just like the math problems we've been doing. Let's do the top real quick. 4 times 12, that's 48. And then the bottom, we're going to work it just like a typical math problem by itself. And I'm going to do the parentheses first. So I have 12 plus 2 times, what's 5 plus 1? Well, that's 6. Now I have 2 times 6. Right here, we got parentheses next to a number. That means multiply. So let's do that next because that comes before the addition right here. So we'll do 2 times 6, which is 12. Then we'll add the other 12, and that's 24. So on the bottom, we'll have 24. Then we take 48 divided by 24, and that's 2. There you go. Take a look at properties. Property is a feature of an object or a rule that is always true. The following properties are true for all numbers. We talked the commutative property. I call it the switching property. Switch. You can see they just switch things, switch order. Addition is commutative, meaning you can switch it and it's going to be the same. You got 6 plus 1, you got 1 plus 6. The associative property is when they take numbers and they reassociate them. We got B plus C, or A plus B plus C is being added first, but in the second version here, it's A plus B being added first, then adding C. And then they give you the arithmetic version of it over here. Distributive property, you can see they're actually going to distribute by multiplying, and this is something we'll actually talk about later in the distributive property. It's easiest to see here, and they're actually taking the number on the outside of the parentheses and multiplying it by each number on the inside. Either way will get you the same answer. And the identity property gets you back to the identity of the number that you're using. So you have the addition version and the multiplication version. When you add 0 to a letter, you have the same letter. A plus 0 is equal to A. A times 1 is equal to A. What does it look like when you actually have numbers in there? Pretty basic there. You see what that is. It's called the identity property. See if you can visualize this example 4. Name the property shown by the statement 2 times the quantity 5 times n, and then they have equaling to quantity of 2 times 5 times n. Well, the order of the numbers and the variables did not change, but their grouping did, so they're different groupings. And therefore, it's associative property. Easy to follow if you're looking at the chart at the top. It's in your book as well. Just name the property here. This is your check. See if you can figure it out before I give you the answers. Ready, go. On this first one here, can you see that they're actually switching x and y? Since they're switching them, this is going to be commutative. I'll abbreviate there. On this last one, the 3x plus 0 equals 3x, that's going to be getting you back. When you add 0, it doesn't change the value. It gets you back to the identity. So we call that the identity property.
Haley Macker to the main office, please.
Is all you have
Haley
there.
Macker to the main office.
Remember, you can always review this video, or you can go read the examples in the book. Maybe you followed me along in the book. Or you can go look at the personal tutors online and the resources for the textbook. And of course, this has been a Friday Shoes production.